Sneha, am I audible now?
Sir, you're audible.
Okay, thank you. Please, whenever the class is started, let me know if
Sir, but
I'm
it's
audible.
cracking in between.
Okay, am I? Is my voice lagging now? Walaikum assalam. Is my voice lagging?
No, sir.
Okay. Okay, thank you. So, in the last class, we have completed our chapter solution. Now I am going to start a new chapter, electrochemistry. Is that okay with both of you?
Yes, sir.
Okay. So let's start electrochemistry. Sneha, what is the syllabus of your unit test? Just syllabus if your unit test.
Sir, what?
What is the syllabus for your unit test?
Sir, my half-yearly exam is
Okay, there will be direct half-yearly exam. Do you know what is the syllabus of your half-yearly exam?
Sir, it's over.
Your half-yearly is over.
Yes, sir.
Okay, very good. Now let's start electrochemistry and let me know if I'm lagging. Okay. So what is electrochemistry? So basically, in this chapter, we will deal with the interconversion of energy. We will deal with the interconversion of energy. I'm going to write it. Please write it. Yes, ma'am. हो गया. Sorry. So basically, what is electrochemistry? It is the branch of physical chemistry. It is branch of physical chemistry which deals with the interconversion of chemical and electrical energy. Chemical and electrical energy. So basically in this chapter, we are going to study or we are going to learn about how a chemical energy will be converted into electrical energy and how electrical energy will be converted into chemical energy. Okay, so please write this. Basically in this chapter, we will study about the interconversion of chemical energy into electrical energy. That means basically how a battery will produce electrical energy, chemical energy into electrical energy, and electrical energy into chemical energy. So first of all, we are going to learn about electrochemical cell. There are two types of electrochemical cell. The first one is galvanic or voltaic cell. Galvanic or voltaic cell. The second one is electrolytic cell. The second one is electrolytic cell. So what is the difference between galvanic cell or electrolytic cell? So basically in galvanic cell, we will study about the interconversion of chemical energy into electrical energy. So here in galvanic cell, chemical energy converted into electrical energy, and in electrolytic cell, we convert electrical energy into chemical energy. Electrical energy into chemical energy. Electrical energy into chemical energy. Chemical energy. So there are two types of electrochemical cell. The first one is galvanic, in which we will convert chemical energy into electrical energy. And in galvanic cell, there will be a spontaneous redox reaction. A spontaneous redox reaction. You have studied a complete chapter in class 11, redox reaction. And in these cells, redox reactions will be there. But in galvanic cell, there will be a spontaneous redox reaction. And in electrolytic cell, there will be non-spontaneous redox reaction. Non-spontaneous redox reaction. So can anyone tell me what is a spontaneous and what is non-spontaneous? In terms of chemistry, what is a spontaneous reaction, you can call it, or a spontaneous process? You have already studied about a spontaneity in class 11 thermodynamics. So first of all, write this and let me know what is a spontaneity or a spontaneous. Fatima, am I audible clearly?
Yes, sir.
Okay, thank you. Let me know if you have any doubt in this. All of you. And also let me know when you are done with this, so that I will change the slide. Hamza, Sneha, Fatima, are you all done with this? Fatima, sorry, Sneha, you are not audible. Hamza, are you done with this? Fatima,
Done, sir.
okay. Please reply in chat box at least if you are not able to speak in the class, or if there is any problem in mic. So now this is basically electrochemical cell. The one galvanic cell is a spontaneous. In galvanic cell, there will be a spontaneous redox reaction. You know what is a spontaneous reaction? A spontaneous process. The process in which the value of delta G is basically gives free energy. Gives free energy. So delta G less than 0, then the process will be a spontaneous. And in non-spontaneous process, if delta G greater than 0, that means positive delta G value will be non-spontaneous. A spontaneity or a spontaneous means basically there will be no need of external agent, like you just need to give them heat, temperature, in heat or pressure or anything that requires. It will happen, or the process will occur on its own. Is that clear, everyone? What is the difference between a spontaneity and non-spontaneity? Hamza, Sneha.
Yes, sir.
Yes, sir.
Okay. Okay. Please do speak up so that I will be able to understand that you understand or not. Now, the next topic is basically conductors. Conductors. So, in previous classes, 8, 9, you have already learned about what is conductor and what is insulator. So, the basically any substance which allows electricity to flow through them is called conductors. So, I'm just going to define it. Substance or substances which allow electricity to pass through them, are called conductors. Here, conductors are of two types. The one is metallic conductor and the another is electrolytic conductors. You can also take an example. Metals, aqueous solution of acids, bases, salts, etc. Graphite is also a conductor. So basically this is the definition of conductor, and conductor are divided into two parts or classified into two parts. The first one is metallic conductor, and the second one is electrolytic conductor. Electrolytic conductor. So can anyone tell me what is the difference between metallic conductor and electrolytic conductor? Please let me know when you are done with this. I'm going to differentiate between metallic conductor and electrolytic conductor. I'm just waiting for your reply so that I will slide it down. Very good. Thank you, Sneha. Hamza and
Done.
Fatima. Very good. Thank you. Thank you. Thank you, everyone. Now see, what is the difference between metallic conductor and electrolytic conductor? So basically, both are conductors. That means electricity will pass through both of them. The one major difference between electrolytic conductor and metallic conductor is that conducting takes place because of free electron in metallic conductor. Conduction you can call it. So basically I am going to write charge carries or charge carriers are free electrons. Charge carriers are free electron, whereas in electrolytic conductor charge carriers are free ions. Charge, or you can take it, charge carriers are free ions. Free ions. Next point we can write flow of electricity takes place without chemical change. There will be no chemical change when flow of electricity takes place in metallic conductor, but there will be chemical changes in electrolytic conductor. So basically I'm going to write another point, flow of electricity takes place or take place by chemical change at electrodes. So basically when we will study electrolysis, you will see there will be change in chemically change at electrodes. Next point we can write, no transfer of matter takes place. No transfer of matter takes place, whereas in electrolytic conductor transfer of matter takes place. Transfer of matter takes place. Transfer of matter takes place in the form of ions. In the form of ions. So when we will study about electrolysis, you will see how the transfer of matter takes place. Next point, resistance is due to vibration of kernels. Whereas resistance in electrolytic conductor is due to viscosity medium. Resistance is due to interionic, one of the reason is also interionic attraction and viscosity medium, and also viscosity medium. Please write it. Then I will again explain and ask some questions. There will be one more important point. That one is Faraday's law of electrolysis. Faraday's law of electrolysis are not allowed. Whereas next point is Faraday's law of electrolysis are allowed. So basically, this point wants to tell you that in electrolytic conductor, Faraday's law follow, and in metallic conductor, Faraday's law, metallic conductor does not follow Faraday's law. Please write it and let me know whenever you are done with this. Then I will again explain these points. Let me know when you are done with this. Very good. Thank you, Sneha. Fatima, are you done with this? Hamza?
Yes, sir.
Okay. So, can you tell me what is kernels? Vibration of kernels. This means basically cloud of electrons. Cloud of electrons. So basically, when cloud of electrons vibrate, flow of electric current will be what we call it opposed. Flow of electric current will be opposed by the vibration of electrons. That's why resistance is due to the vibration of kernels or vibration of electrons cloud. You know what is resistance? Basically, the property of any conductor which does not allow current to pass, or you can call it the flow of current is opposed by a property. That property is called resistance. Is that clear to everyone? Hamza, Sneha, and Munir, Fatima, Munir. Now, see this. Resistance is due to interionic attraction. So basically, in electrolytic conductor, the conduction is because of the flow of ions. And when there will be attraction between ions takes place, when there will be attraction between ions, the flow of ions will be slower. That's why resistance is due to interionic attraction as well as viscosity medium. Viscosity medium is basically friction in fluids. So due to this friction in fluids, the flow of ions will be opposed. The motion of ions will be opposed. That's why one of the reason is there will be another reason of resistance in electrolytic conductor, that will be viscosity medium. So please remember these points, which are very important. Charge carriers are free electron, and here charge carriers are free ions. Next point, flow of electric current takes place without chemical change. If you are going to flow a current in metallic conductor, there will be no change by chemically. There will be no chemically change. But when we talk about electrolytic conductor, that means free ions will travel from one electrode to another electrode. So there will be chemically change. There will be chemical change. Next point, this in metallic conductor, there will be no transfer of matters. But in case of electrolytic, when ions will from one electrode to another electrode, there will be transfer of atoms. There will be transfer of matter in terms of or in form of ions. Also, this fourth point, resistance is due to vibration of kernel, and herein resistance is due to interionic attraction and viscosity medium and viscosity medium. And the next point, which is very important, Faraday's law. In metallic conductor, Faraday's law does not followed, and in electrolytic conductor, Faraday's law followed. Okay. Now I'm going to change the slide and going to introduce a new topic, that is electrolytic conduction. In this first lecture of electrochemistry, we are going to only talk about the current part of electrical part of electrochemistry. Okay, so the next point is basically electrolytic conduction. Electrolytic conduction. And here we are going to introduce some new term that you already know about, that you already know, such as resistance, resistivity, conduction, conductivity, these all terms. Now see, the first term is basically resistance. And we know that resistance is denoted by, or the symbol of resistance is R. So resistance, I'm going to define it, the property of conductor which opposes the flow of current, you can call it flow of current or charge, is called resistance, Now by Ohm's law, we will get a formula that you have already studied in class 10 by Ohm's law. Ohm's law. You know that V equals to IR. V equals to IR. So R will be equal to V upon I. There will be this formula. And we also know about the unit of resistance. Unit of resistance is ohm. Unit of resistance is ohm. And it is denoted by this symbol, ohm. So please write about it. Let me know when you are done with this. Everyone done with this? Fatima, Hamza, Sneha. Thank you, Sneha. Okay. Hamza, are you done with this? Fatima?
Done, sir.
Okay, thank you. Now, the next term in this is basically after resistance, this is conductance. The next term is conductance, and conductance is denoted by, or the symbol of conductance is Z. So, what is conductance? So, it is basically the conduction, the conductance of a conductor is equal to the reciprocal of resistance, is equal to the reciprocal of resistance. So we can get a formula from this statement. G will be equal to 1 by R. This is the reciprocal of resistance. G equals to 1 by R. And now unit of conductance is basically, we can write it per ohm. We can read it per ohm, or if you are going to symbolize it, you can write it as per ohm. Okay. Another unit, we also call it ohm as mho. Mho, and its symbol is basically this, opposite of ohm. And we can also call it Siemens, and this Siemens is denoted by S. So you know that from this formula you can easily calculate the unit of conductance, that is 1 by ohm, that you can also write it ohm per ohm, or per ohm is also known as mho, and we can also call it mho as, wait a minute, mho, or we can also write Siemens. Siemens. So these all are same, only the name change. Siemens. Okay. I hope you got it. If you have any doubt in this, please let me know. Unit of conductance is per ohm. You can write it like this. Per ohm is also known as mho. That the symbol of mho is this. And per ohm is also known as Siemens. And we denote Siemens as S. Please let me know when you are done with this. I'm waiting. Thank you, Sneha. Hamza and Fatima, are you done with this?
Yes, sir.
Okay. Now see, the next term is basically the third term is a specific resistance. A specific resistance, or we also call it resistivity, and we denote it by rho. Rho. So basically, how we are going to define it? We are going to define it with the help of a derivation. Length of conductor, that is L, directly proportional to resistance, or you can call it, wait a minute, resistance is directly proportional to length of conductor L, length of conductor L, and resistance is also directly proportional, inversely proportional to the area of cross section A. You know what? If the length of conductor is lengthy, or if you have a wire or a conductor which is very lengthy, the resistance will be high. And if you get a wire which is thicker, the resistance will be smaller. Now, after joining this and this equation, we will get resistance directly proportional to length and inversely proportional to area. And to remove this proportionality sign, we will get an proportionality constant, that is rho, and rho is resistivity or a specific resistance. And we can easily find a formula for rho that will be equal to A into R, or A by L into R. This is basically formula of rho. Now we can also find if you know the formula, you can easily find the unit of that quantity. You know the unit of area will be meter square, and unit of length will be meter, and unit of resistance is ohm. So after cancelling it, you will get ohm meter, or you can also call it ohm centimeter according to the requirement. So this will be the unit of resistivity or a specific resistance. Please write it. Let me know when you are done with this. There will be 3 more terms, and after that we will do some numerical on this topic. Is everyone done with this? Hamza, Sneha, Fatima. Thank you, Sneha. Fatima.
Done, sir.
Thank you. Thank you, Fatima. Hamza, are you done? Now see, the next term is a specific conductance, or you can call it conductivity. Conductivity. And this is denoted by kappa. This is called kappa. K like a structure, small k like symbol, that is called kappa. Okay, so I'm going to define it. It is defined as, wait a minute, it is defined as reciprocal of resistivity or a specific resistance. So basically kappa or conductivity is reciprocal of resistivity. That means kappa will be equal to 1 upon rho. Can I write it like this? Kappa is equal to 1 upon rho. Now I am going to derive another formula of kappa, that is conductivity. You know that, we already know that resistance is equal to rho L by A. This was the formula for resistivity, also we can call it. Now inverse of this, that means 1 upon R will be equal to 1 upon rho into this. A will be in numerator and L will be in denominator. After inversing it, we will get this or not? Yes or no? Please let me know. We will get this. 1 by R is basically conductance. Reciprocal of resistance is called conductance. So this is conductance that we denote it by G. And 1 by rho is the reciprocal of, this is the reciprocal of resistivity, which is known as conductivity. So this is our kappa. This is our kappa, rho L by A. Okay. And this term, did I do mistake? No. Wait a minute, please. Okay, wait a minute. Just don't inverse it. I'm going to redefine it. Is this okay? It's also good, but I want to make it again. Please write it. Are you done with this? Yes or no? There was no mistake, but it will be just in 2 or more steps. That's why I just erased it. I will do this in another method, with another method. Are you done with this, everyone? Please write it and let me know. Very good. Thank you, Sneha. Hamza and Fatima, are you done with this? Please let me know. Wait a minute. Then thank you, all of you. Now see, from this formula, I can easily write the formula for rho that we have already written above. Rho will be equal to L by A into R. This was the formula for resistivity. Now see, I'm going to write the inverse of this. Inverse of above formula. If I'm going to inverse this formula, it will be 1 by rho will be equal to oh, I just made a mistake. Sorry. This A will be here and L will be here. Now see. So if I'm going to write the inverse of this, we will get L by A into 1 by R. We will get this or not? Please let me know yes or no. Reply me. After inversing it. Now see, you know that inverse of rho, that is resistivity, is called kappa, conductivity, and inverse of resistance is called conductance, that is G, and this L by A is known as G star, that is cell constant. I will define it soon. So I can write conductance equals to cell constant. I will define it cell constant now. Cell constant into wait a minute. Conductivity will be equal to cell constant into conductance. Sorry, I just got confused. Conductance, conductivity. So this will be the new formula for conductance, that is kappa will be equal to G star, that is known as cell constant, and that is known as cell constant and into conductance. Please write it. Now I'm going to just define its cell constant here. Please see this. This cell constant is denoted by G star, and we define it ratio of length of conductor L to area of cross section of conductor, So basically this is very easy to understand. G star is basically cell constant, and cell constant is what? Ratio of length of the conductor upon area of the cross section of conductor. So this is the cell constant. And if you are going to talk about the unit of cell constant, so you know that unit of length will be meter and unit of area will be meter square. So we can write it per meter or per centimeter according to our requirement, per meter or per centimeter. Please write. Now let me know if you have any doubt in this. Is this clear to everyone? Sneha, let me know when you are done with this. Fatima and Hamza. Very good, Sneha. Fatima, are you done with this? Hamza? Okay, now the next topic, the next term is basically very important in this chapter. The fifth one is basically molar conductivity or molar conductance. Molar conductivity, or we also call it molar conductance. You have already studied about this molar and equivalent in class 11. So basically, what is molar conductivity and molar conductance? Since we are studying about electrolytic conduction, so please listen it carefully. The conductance due to, when we define molar, the conductance due to 1 mole electrolyte, the conductance due to 1 mole electrolyte is known as molar conductivity. And if we are going to talk about equivalent conductivity or equivalent conductance, that means the conductance due to 1 gram equivalent electrolyte, that is equivalent conductivity. So I'm going to just define it. Please write it. And also we denote it by mu, lambda, and all. We denote it by mu, lambda m, and also like this. This is the symbol of molar conductivity and molar concentration. So I'm going to define it. It is defined as the conductance. It is defined as the conductance of all the ions, or it is defined as the conductance of all the ions produced by 1 mole electrolyte present in given solution. Or you can call it given volume of solution. Given volume of solution. So it is very easy to understand what is molar conductivity. So the conductance produced by 1 mole electrolyte present in given solution, that conductance is known as molar conductance. Okay. So there will be formula which is very important. Molar conductivity, that means lambda m, will be equal to conductivity kappa into volume. Whatever is the volume, and you are going to multiply it by kappa conductivity, you will get your molar conductivity. Now, V equals to volume of given solution, or you can call it volume of solution containing 1 mole of electrolyte. 1 mole of electrolyte. That means V is volume and it contains 1 mole electrolyte. So if concentration, we are going to derive a formula. If concentration of solution is m is the concentration of solution, that means molarity, m mole per liter, m mole per liter, that means the volume is 1 liter, then we will have a formula. Then lambda m, that means molar conductivity or molar conductance, lambda m will be equal to kappa into 1000 upon molarity m. This 1000 is because we just need to convert it in molarity is always, whenever we calculate molarity, we put volume in liter, that's why we just multiply it by 1000 and you will get a formula. Lambda m will be equal to kappa into 1000 upon m. Now its unit is very important. You can see unit of lambda m, that means molar conductivity, is what is the unit of kappa? Do you know what is the unit of kappa? Per ohm, per ohm, and this will be basically centimeter square per mole. Kappa has a unit. I already told you. Wait a minute. Did I define the unit of kappa? Conductivity, specific resistance, resistivity. Oh, sorry, I didn't tell you the unit of this kappa. Unit of conductivity kappa is, as you know that unit of ohm meter, sorry, rho is 1 by sorry, this is ohm per meter, ohm per meter, or you can call it ohm meter or ohm centimeter. So if you are going to define the unit of kappa, it will be per ohm per centimeter, and you can also call it per ohm as Siemens per centimeter, or you can also call it mho per centimeter. So this will be the unit of kappa. Please write it. I forgot to tell you about the unit of kappa, and you also didn't ask anything. I will be thankful to all of you if you will, three of you, if you will just talk to me while I am teaching you. Whatever I am asking, at least message me in chat box, because I don't get you whether you are understanding the concept or not. This is very bad. Hamza, Sneha, Fatima. No one is saying anything. Very disappointed. Are you done with this? Now see, the unit of lambda m will be per ohm centimeter square per mole, or we can also call it Siemens centimeter square per mole. So this will be the unit of molar conductivity and molar conductance. Please do write it. Let me know when you are done with this. Thank you, Sneha. Fatima, are you done with this?
Yes, sir.
Okay, thank you. Now, see, I'm going to introduce another term, that is equivalent conductivity and equivalent conductance. In equivalent conductivity or equivalent conductance, lambda EQ, lambda EQ. Symbol of this, and now I'm going to define it. It is defined as the conductance due to all the ions produced by 1 gram equivalent of electrolyte in the given volume of solution. So basically, equivalent conductivity, 1 gram equivalent. You have studied in class 11 equivalent concept and mole concept. When we talk about molar conductivity, that means conductance due to all the ions produced by 1 mole electrolyte. And when we talk about equivalent conductivity, conductance produced due to all the ions by 1 gram equivalent of electrolyte. So in the same way, we can have a formula, lambda EQ will be equal to kappa conductivity into volume. Also, in the same way that we have uh, derived a formula for molar conductivity, we can derive a formula for equivalent conductivity if V equals to volume of solution containing 1 gram equivalent of electrolyte if concentration, since we are talking about equivalent, so we will take normality in the same way that we took molarity in case of molar conductivity. So if concentration of solution is n gram equivalent per liter, then we will have a formula that is lambda EQ will be equal to kappa into 1000 upon n. and also unit of equivalent conductivity will be per ohm centimeter square per equivalent. This is EQ for equivalent, per equivalent. And in terms of Siemens, we can have another unit, that is Siemens centimeter square per equivalent. Please write it. And let me know if you are done with this. Let me know when you are done with this. Very good, Sneha. Everyone done with this? Hamza, Fatima, can I change the slide?
Yes, sir.
Okay. Now write a question. Questions on this topic will be purely formula based. Resistance of a 1N, that is stand for normality. 1N solution of salt is 50 ohm. Is 50 ohm. Calculate calculate equivalent conductance of the solution. If the two platinum electrodes in solution are 2.1 centimeter apart and each having an area of 4.2 centimeter square. Very easy question, purely based on formula. Please apply the formula and let me know the answer. I am waiting. Ah. Let me know if you are unable to solve it. Any answer? Very good, Sneha. Fatima, can you do it or you need an explanation? Hamza? The resistance of one normality N is given. Resistance is given. and we need to calculate equivalent conductance. And equivalent conductance has a formula, is equal to kappa into 1000 upon n. Now kappa is not given directly, so we can easily calculate kappa. First of all, we need to calculate kappa. Kappa will be equal to 1 by r into L by A and 1 by 50. And what is the length of conductor? That is 2.1. And area of the cross section, that is 4.2. So you can easily cancel it by 2 times. And it will be basically 1 by 100. That means 10 raised to the power minus 2 Siemens per centimeter. Now I'm going to put this value here. 10 raised to the power minus 2 into this 1000 can be written as 10 raised to the power 3. And what is the value of normality? That is 1. So we can easily calculate it. 10 Siemens centimeter square, since it is equivalent. So I'm going to write it per equivalent. If it is m molar conductivity, then per mole it will be here. Please write it. Let me know when you are done with this. Hamza, are you done with this? Can I change the slide?
Done, sir.
Okay. Now next question. Which of the following have, this is for homework, which of the following have maximum molar conductivity? The first one is 0.08 m solution and its specific conductivity is 2 into 10 raised to the power minus 2 per ohm per centimeter. You just need to compare it. And the second is 0.1 m solution and its resistivity is 50 ohm centimeter. So please write the question. This is it for today. Thank you. Everyone done with this? Hamza, Fatima, Sneha. So this is for homework. I'll see you tomorrow at the same time. Fatima and Hamza. Sneha, write the question. I'll check it by tomorrow. Okay, thank you so much.